Good afternoon. Now we are going to see which are the clauses are related with slabs. So we have plain and reinforced concrete code of practice. Page number 48, we have the rules given. 26.5.2.1 and 26.5.2.2 shall apply to slabs in addition to those given in the appropriate clauses. So minimum reinforcement, already we have seen many times. That is for mild steel, we have 0.15%. And for tor steel, that is Fe 500 and Fe 415, we have 0.12%. Maximum diameter of bar that is given in slab, and we have given maximum. So maximum dia in slabs, and that should not be greater than, we have 1/8 of the total thickness. So d upon 8, where d is depth of slab. So d of slab upon 8. So your maximum diameter should not be greater than, or we can say it should be less than or equal to d slab by 8. These are actually two main criteria which are related with your slab given on page 48. Now we have page 90. Now I'm switching to two-way slabs. So we have two types of slab in two-way. One is restrained slab and another is simply supported slab. So we have already seen when we will say two-way slab. So if Ly by Lx that is greater than 2, then we have one-way slab. And when Ly by Lx less than 2, then we have two-way slab. So now restrained slab, we have D dash 1.1 to D dash 1.11. All these clauses are related with your two-way slabs. Now D dash 1.1, that is given bending moment along x direction, y direction. We have this component same. This is WLX square and this is also WLX square. So these are same. So Lx is shorter dimension. Lx shorter dimension considered as span, and Ly longer dimension. Now change we have in this alpha x and alpha y. And this alpha x and alpha y, these are actually given in table 26, page number 91. And you can see we have these values. So if you will see bending moment coefficients, so here they have mentioned bending moment coefficient for rectangular panel supported on 4 sides. So when slab is supported on 4 sides, we are going to consider two-way slabs. If it supports on longer side, then we are going to say one-way slab. One-way slab always supports on longer side, and therefore we are going to transfer load of slab on longer side and not on shorter. On shorter side, we do not have any load of this slab. That already we have seen. So with provision for torsion at corners. Now you can see we have given now 9 cases. So now in this, we have given interior one short edge continuous. So actually it should be one short edge discontinuous. That you have to keep in mind. Then we have one long edge discontinuous, then two adjacent edges discontinuous, two short adjacent edges, then we have two short edges, then two long edges, three edges discontinuous, one long edge continuous, and three edges discontinuous, one short edge continuous. So here also one short edge continuous, and here also. So we have these two same, and therefore that is actually we have one short edge discontinuous. And here we have one short edge continuous. So here we have three edges continuous in 2, and in 8 we have three edges discontinuous, and last 4 edges discontinuous. So we have only all 4 edges we have discontinuous in this, and therefore you do not have any negative moment. because as these are discontinuous, we do not have value. So whichever edge, now you can see two long edges discontinuous. So we do not have bending moment along this. So whatever we have 1 to 2, these are for short span. And values we have Ly by Lx, that is 1 to 2, because we know value. Sometimes they may ask why that is up to 2, because when Ly by Lx that goes greater than 2, then your slab becomes one-way slab, and therefore this is not applicable. Students are saying no, we can find it, or maybe no, because whenever Ly by Lx greater than 2, it will act as one-way slab. So up to 2 we have these values. Negative values gives you bending moment at supports. So these are at support, and positive values gives you at mid span. These are, or I can say span moment, not we can say maximum, span moment. So positive gives us span moment and negative gives us support moment. So these are given table 26, page 91. Now we can have slabs are considered as divided in each direction into middle strip and edge strip. Now you can see over here. So we have that is middle strip and then edge strip. And in middle strip, we are going to provide the reinforcement as per the calculated value of AST. And in edge strip, we can provide that value that has minimum. So they have mentioned. So you should know this value is 3/4 Ly, and on this side we have 3/4 Lx. It is not Lx on both sides. One side Lx, one side Ly. So if you are along Ly, it will be 3/4 Ly. If along Lx, we have 3/4 Lx. Then they have given the maximum moment calculated, apply only to middle. So only middle we are going to apply. If I will draw in this value, that is Lx by Ly. So we have this portion where we have to provide main reinforcement. Now this already we have seen 0.25 L of a discontinuous edge and 0.15. So these values we are going to provide from center of support. Center of support. And these values at support, we are going to find it from face of the support. Face of the support. So for bottom reinforcement or for negative, we have 0.25 L and 0.15 L for sagging, and for hogging, we have 0.15 L and 0.3 L alternately. They have clearly mentioned over here. We have provided also. So you should be in position to answer for this. Then at a discontinuous edge, 50% we are going to take inside the support, and we can have 50% bent up, or we have to provide that is point L into the span. Again, this we have to provide from face of the support. That is whenever you are providing that is top side, that is hogging side, then we have from face of the support, and sagging side we have from center of the support. Now reinforcement in edge strip, I already mentioned, it will be minimum given in section 3, and the requirements for torsion given in D-1.8. Now here this is mentioned. Torsion reinforcement shall be provided at any corner where the slab is simply supported on both edges, meeting at that corner. Means if I will draw a diagram, and if we are in this fashion, so I will draw 3 slabs. So 1, 2, I will draw 4 slabs. Now you can see at this corner, we are assuming simply supported on both sides, and value they have given, that is it shall consist of top and bottom reinforcement, and each layer of bars placed parallel, and the area of reinforcement in each this shall be 3/4 of maximum mid-span moment, 3/4 of ASTX max, when both edges are discontinuous. Here both edges discontinuous. Both edges discontinuous. That is most important. because in this case, whatever moment, torsional moment will be developed will not be considered. Now, then we have 3/8 when one edge continuous, other edge discontinuous. Here we have one edge discontinuous, one edge discontinuous, other continuous. One edge discontinuous and other continuous. Other continuous. Then we are in this fashion. That is 3/8 of AST max. Half of this, that is half of 3/4. So it becomes 3/8 of 8 AST max. And when we are both edges continuous, so this edge continuous, this edge continuous, no torsion reinforcement. No torsion reinforcement, because torsion developed from both sides will be balanced, and therefore we are not going to provide any torsional reinforcement. Both edges continuous. Both edges continuous. Now, actually, what is a restrained slabs? Restrained slabs means corners held down. Corners held down, or we are saying not allowed to lift up. Not allowed to lift up. So whenever we are going to restrain anything, moment will be developed, and to resist that moment, we have to provide reinforcement. Here we have torsion, because lifting means we are moment perpendicular to the plan of the slab, and as it is perpendicular to the plane of the slab, therefore it will be torsion. And if corners held down, torsion will develop, and we have to provide torsional reinforcement. If corners are allowed to lift up, or we are not going to hold corners, that means they are free to lift up. In that case, we need not require any torsional reinforcement. So now here you can see Ly by Lx is greater than 2. That will be one way. And if it is less than or equal to 2, we can say, then we have two-way slab. And therefore that values are given 1 to 2. Then we have simply supported. I already mentioned corners are allowed to lift up. Corners are free to lift up. To lift up, or not held down. Not held down. And then we have simply supported slabs. Then formula we have same, no change in the formula, but we have to take values from table 27. There we have to take from 26. Now here you can see we do not have value of negative moment, because we have simply supported. So we have only span moment, that is positive moment, and which we have to provide in middle strip. Middle strip. So this moment, that is for middle strip, reinforcement we have to provide. Reinforcement we have to calculate by using this, and reinforcement that for that moment will be in middle strip, and in edge strip we have to provide it as minimum. Again, you can see this value we have given 1 to 3, but we have 1 to 2. Then we have given 50%, that already we have seen. We have to take inside the support, and remaining 50 we can bend up or we can curtail it. So we have clauses for slabs in this fashion. Now we will stop here only. Remaining part we will see in the next video. Thank you.